everyone. So today we are doing a topic which is very important, and students generally struggle with this topic. This topic is stoichiometric problems. So let's start with this topic. Let's consider a reaction, a very general reaction. C plus O2 gives CO2. If you see the coefficient over here, this is 1. The coefficient of carbon is 1, the coefficient of oxygen is 1, and the coefficient of carbon dioxide is also 1. So using mole ratio, we can say that this is 1 mole carbon reacting with 1 mole oxygen to give 1 mole of carbon dioxide. 1 mole of carbon has a mass of 12 grams. Similarly, 1 mole of oxygen has a mass of 32 grams. And 1 mole of carbon dioxide has a mass of 44 grams. Now, this shows that 12 grams reacts with 32 grams, giving 44 grams. This also proves the principle of conservation of mass. Now, there will be two types of questions that comes in these type of problems. In the first part, we are discussing when the excess reactant is already given it to you. For example, in the question, if it's given carbon is given as 6 grams and oxygen is in excess. They have already given that oxygen is in excess. To find the mass of carbon dioxide, you have to find the mass of carbon dioxide. Now, so to solve this, we just have to use this as the reference line. I consider this as a reference line. It is given that 6 grams of carbon and excess oxygen. So don't need to consider oxygen over here. And we have to find the mass of carbon dioxide which is produced. Using unitary method, we will find x. So x is equal to 6 into 44 divided by 12. This gives you 22 grams. So if 6 grams of carbon is present, then 22 grams of carbon dioxide is formed when oxygen is taken in excess. Let's solve this question, which was there in IGCSE exam. The question says that the reaction of iron 3 oxide with carbon monoxide is shown. The reaction is shown. You have to find the maximum mass of iron that can be made from 480 gram of iron 3 oxide. Now, in this question, we know that carbon monoxide mass is not given. That means you have to solve it using carbon monoxide as excess. So let's write down the reaction first. Two Fe plus 3 CO2. Now, if you see, the coefficient of Fe2O3 is 1, so we'll write 1 mole of Fe2O3 reacts with 3 mole of CO to give 2 mole of Fe and 3 mole of CO2. Now, 1 mole of Fe2O3 has a mass of 160 grams that you can calculate by using the atomic masses of iron and oxygen, which is 2 into 56 plus 3 into 16. I hope you already know this how to calculate the molecular mass. 160 gram is the mass of 1 mole of Fe2O3, and 3 multiplied by 28, because 28 is the mass of carbon monoxide. Then 2 into 56 and 3 into 44 grams. So now this is my reference line. This is my reference line. Now in the question, they ask if we have 480 grams of iron 3 oxide, 480 grams of iron 3 oxide with excess of carbon monoxide, find the maximum mass of iron which is produced. Maximum mass means they are asking for the theoretical mass, and that's how we calculate the theoretical mass. Let's suppose this is X. Using unitary method, we will find X. X is equal to 480 multiplied by 2 into 56 divided by 160. Now, if you calculate this, this comes out to be 336 grams. I hope you understood this. Now, for this type of question, where they ask for the volume of CO2 produced, you first have to note a very important statement. 1 mole of any gas occupies a volume of 24 dm cube at RTP. RTP means room temperature and pressure. So any gas, 1 mole of any gas has a volume of 24 dm cube. Using this information, we will solve this question. So we will write the equation here. CaCO3 plus 2HCl gives CaCl2 plus H2O plus CO2. Now the mole ratio is 1 mole, 2 mole, 1 mole, 1 mole, and 1 mole. To write the reference line, we should know the molecular masses. You can calculate the molecular masses. The periodic table is already given to you in the paper. So this is 100 grams. This is 2 into 36.5 grams. This is 111 grams. This is 18 grams. And this is 44 grams. Now we know that in the question, it's given 0.5 grams of calcium carbonate. See, this is the reference line now. This is my reference line. Zero 0.5 grams of calcium carbonate, and they have already given excess of dilute hydrochloric acid. No need to consider dilute hydrochloric acid. They're asking for the volume, but first we'll find the mass of the carbon dioxide. Now cross multiplication. So X is equal to 0.5 multiplied by 44 divided by 100. This gives the mass as 0.22 grams. Now, but we need to find the volume of CO2. So we consider that 1 mole has a mass of 24 dm cube, any gas, and this gas, 1 mole of this gas weighs 44 grams. But we have 0.22 grams. We need to find the volume. Let's consider this is y dm cube. Again, to find y, we will use unitary method. Y is equal to 0.2 multiplied by 24 divided by 44. This gives 0.12 dmq. So this is the volume of CO2 reduced when zero point 0.5 grams of calcium carbonate is present. Option A is correct. So I hope you understood this concept of calculating the mass and the volume. Now in the next part, we are going to understand what is limiting reactant, and we will solve question related to that. Thank you.